currently a graduate assistant for SARC, and I have been an Orgo tutor for the past 2.5 years. So I've definitely picked up a few tips and tricks of the trade. I'm currently pursuing a master's in chemistry, and I have my undergraduate degree in forensic biochemistry. So you're in good hands, and hopefully we're going to learn some tips and tricks to make Orgo more approachable and less scary today. So kind of on our agenda, breaking it down into three major topics. Our first one is going to be textbook tips. In organic chemistry, your textbook is very large, right? Very intimidating. You're gonna have to find some way to try and break that content up. The second thing we're gonna be tackling is managing mechanisms. And then lastly, remembering reagents. Are you all in Orgo 1? Because I know you're probably around that time where you're getting a lot of reagents thrown at you. Ooh. Yes, no, I figured as much. So this will be really good going into chapter 7, chapter 8 territory when you start to have to remember all those reagents. So starting off with our textbook tips, one of the most common things I hear students say is, I'm going to read the whole textbook. Guys, please don't say that. Please don't say that. I have a little meme here. This is me anytime someone says that they're going to read the whole textbook, because that is definitely not the play. So for a bit of a breakdown, there are 634 pages in just the Orgo 1 section of the textbook. And there are about 140 problems per chapter, and Orgo 1 goes up to chapter 13. So just doing some quick math here, trying to read the whole textbook, trying to do every single problem in the textbook is simply unrealistic. And when you start to set that standard for yourself, what I find with a lot of students is they get burnout really, really quickly. And they might not study as much as they would have because they've set such an unrealistic goal for themselves. So with that in mind, how can we make the most of our studying when it comes to the textbook? Well, I do have a few techniques. So one of my first technique is to start with what is called the skill builder section. And so this is sections in between the text that break down smaller chunks of new info. So how it's set up is it'll introduce you to a brand new concept, and then immediately after that concept, you'll have the skill builder so you can practice it. And the best thing about the skill builder is that the difficulty increases over time. So you don't have to do every problem. Hi, welcome in. So the best part is you don't have to do every problem. That's another thing that I hear everyone say all the time, is that they want to do every problem in the textbook. That's also simply unrealistic. So what I recommend is when you get to one of these skill builder sections, what you can do is self-test to determine your level of understanding. And what I mean by that is, usually if you guys have watched and looked for the textbook, you'll see there's sections like A through K. So question A is going to be the easiest, most base level question, right? Question K is going to be the hardest one. So start somewhere in the middle. And if you can solve that one, there's no reason for you to sit around solving A, B, C, D, right? You can save yourself a lot of time. So this is a method I kind of use to make the textbook more approachable and make sure it was working for me as well, and that I wasn't just trying to brute force my way through all of the content. And see, we have something in chat. Let's check that real quick. Okay, so next tip is practicing the ACS style questions. So if you're not aware, your final is going to be ACS style. So one of the common questions I hear is, well, what does ACS style even mean? So ACS style in the context of Orgo 1 basically means that the Orgo 1 professors are going to come together and make a packet of multiple choice questions. So your final is going to be all multiple choice. You don't have to worry about any free response. And so a lot of questions tend to be around, well, how do I get practice for multiple choice questions? So the best ways to do that is through the ACS style, which is at the end of each chapter of the textbook. And this is really going to help you specifically with how they like multiple choice questions. Because you guys have had probably 2 organic tests by now, and I know for a fact they like to word it very particular to try and trip you guys up in their wording. So they take a lot of that wording and a lot of that inspiration from the ACS style text at the end of your textbook. Sweet. So another good thing about practicing the ACS style questions is, don't you hate when you're practicing, but you don't really know how well you're doing? Like you're chugging through questions and you're like, I sure would like some feedback. Well, a lot of people don't seem to know this. Your textbook, the online version, and the physical one as well, every problem comes with an explanation at the back of the textbook. So the reason why the problem numbers are underlined and in that different font color is because it's a hyperlink. So you can click on it and it takes you to a breakdown of every single question in the textbook. So it's definitely a good resource to use. So that way you're able to compare. I wouldn't recommend going to it first before you attempt solving the problem. Attempt it first and then check your work. Sweet. And the other thing I love a lot is the textbook has a lot of visuals. So there's a lot of concept maps that you're going to be able to use. So some examples of what you can do with them is you can erase steps in mechanisms and then fill them in yourself. And then one of my favorite is what I call the webs. So I'm going to move this on Zoom so we can kind of, oh, that did the exact opposite of what I was trying to do. There we go. Move this over here for a second. This is an example of the web. So you might not be familiar with them yet because it should be in the chapter that you're getting into soon, but it summarizes every single reagent that you learn within a chapter. And trust me, there's gonna be a lot of reagents thrown at you. I see you slow blinking already. You know the terror that's coming. But it doesn't have to be terror, right? So it offers a really great summary, and it's a really great way to wrap up the chapters and make sure that you didn't miss any. Because, I mean, look how many are on that one. It's easy to gloss over one. Make sure you got everything. So how I like to practice with this one is there's 2 ways you can approach it. You can either erase these sections. So you see these sections here, those are like your products. You can erase your products and then test yourself by redrawing them in. Or another way you can practice is you can actually erase the reagents and practice writing those in, because ultimately you will need to be comfortable with both. So really great way to practice. And then this one we'll talk about a little later on. I live and die by this figure. It's called figure 7.18. I won't talk too deeply about it right now because, like I said, he makes a very special appearance in the presentation. But the more you can actively interact with what you're reading, the better you'll be able to recall important details. So that's another thing that I see a lot of students do is they'll have the textbook in front of them and they'll just read and they'll flip through. But the problem is if you're not interacting with it, it's going in one ear out the other. It's like when the professor lectures at you for 2 hours straight. You're not retaining all that information. You have to find some way to interact with the content, and then it's going to stick a little better. Sweet. Sometimes I just don't be breathing. So the next one we're going to get into is managing mechanisms. So like I said, I'm a little foggy on where you're at right now in content-wise. I know there's many professors who are probably working at different paces, but chances are you've maybe seen the beginnings of mechanisms. So all mechanisms are built from a few building blocks. But one thing that I noticed while I was an Orgo tutor is that oftentimes these building blocks get rushed through because it's a lot of chapter 6 content. And it's kind of like a weird, awkward in-between chapter that professors like to assign you to read at home a lot, which isn't always the best because it's building those fundamental steps to those larger mechanisms. So one thing that people really don't realize in organic chemistry is the importance of definitions. we really get to a point where definitions are essential to understand what you're learning. And so when professors skip over chapter 6 and we jump straight into chapter 7, maybe you've already noticed, they'll start throwing around terms like nucleophile, electrophile, carbocation. And students panic because they're like, oh my gosh, what are they saying? So those definitions are certainly important to put in your notes. So I've included a few important ones right here. We have nucleophile and electrophile. These are going to be some of your foundational stuff when it comes to mechanisms and reagents. It's going to help you understand the process behind what's happening. So a nucleophile refers to areas of negative or partial negative charges. So we have an example right above it. You can see this oxygen has a negative charge. So it's going to be acting as a nucleophile. Another important thing about nucleophiles is that they are attracted to positive charges or protons. So you can kind of think of this like a magnet where opposites attract. And then the other one we have is electrophile. So the nice thing about it is they're exact opposites. So if you remember one, you can usually remember the other one. So our electrophiles are areas of positive or partial positive charges, and they're usually attracted to negative charges or electrons, right? So if you ever forget which one is which, another good thing is that chemists aren't creative, okay? Usually it's all in the name. So if we break it down, we can use electrophile as an example. That end bit, phile, is it a suffix or, yeah, it's got to be a suffix, is a suffix, and it means lover. So if we're an electron lover, then chances are we have a positive charge because we're attracted to the electrons. And you know, you can remember that any way you like, so. Another good bit of important definitions are getting into the arrow pushing methods. Have you guys gone over arrow pushing methods, or was it one of the ones where they kind of left you to your own devices? Okay, I don't think they put enough emphasis on these arrow pushing methods because these are going to be the foundational building blocks of knowing how to draw those arrows in. I don't know if you've had any experience with any of those type of questions yet, but it'll be very common free response question that you get will be, can you draw in the arrows for this mechanism, right? So usually whenever you're trying to draw an arrow, it's actually not too bad because you pretty much have 4 options and that's it. So your first option is a nucleophilic attack. And didn't I promise that chemists are not very creative when it comes to naming things? Because when you know it, a nucleophilic attack is when a nucleophile attacks an electrophile. So a positive attacking a negative. Again, loss of a leaving group. Gee, I wonder what happens in this one. A group leaves, period, that's it. Proton transfer, now this one can be a little tricky because the other thing about chemists is everything's got to have 50 names. So proton is usually used as a stand-in for hydrogen. So we can kind of break down why that is do you guys know how many electrons does hydrogen have? Huh? One. Yeah, say it with your chest, you got it. Yeah, it has 1 electron. So if it loses that electron, it's left with only 1 proton. So that's why they usually use it interchangeably. But I do see some people are like, well, we don't even draw in protons. Whenever they say proton, they really mean hydrogen. They're lying to you. And then lastly, we have rearrangement. So rearrangement is when something that already exists on the molecule is shifting places on it. That's all it is. And you can have different kinds of rearrangement as well. You could have carbon rearrangement. You could have hydride rearrangement. And again, they're not creative. It tells you exactly what's being rearranged. So these are going to be our fundamental building blocks when it comes to making those mechanisms. Sweet. Any questions? I'll pause for the people online. Any questions online? Going once, twice. Oh,
No questions.
no questions? Okay. Yay. Okay. So another tip is when looking at a new mechanism, try to determine what arrow pushing methods were used. So when you're going through your textbook, it'll show you the starting point and the end point, and there'll be like 30 arrows in between doing a bunch of complicated stuff. Well, you know the 4 building blocks now. So you can go in step by step and you can say, here, there was a proton transfer. Here, there was a nucleophilic attack. And just being able to identify those is going to do wonders when it comes to understanding the mechanism and being able to recall it when it comes to a test. Sweet. So getting into our other category here, remembering reagents. Didn't I say he would make a comeback? I'm telling you guys, I live and die by this chart. Figure 7.18. So this is part of chapter 7, which from my understanding, you guys are probably starting to get into chapter 7 sometime soon. So before you approach a problem, you need to know what reaction will occur, right? So figure 7.18 is a summary of what reactions occur under what conditions. It is basically an entire summary of chapter 7. And look, I am foaming at the mouth whenever I get an opportunity. You know how long those chapters are. Anytime they give you a summary, especially in a visual, that is going to be essential for your understanding. Hi, welcome in. So I really like how this one is set up too. So a little breakdown of what we're seeing here is along the top where it says strong base, weak nucleophile, strong base, strong nucleophile, all of this is describing your reagent. So if you're looking at the problem, your reagent is what's like on the arrow part. So you have to identify what kind of reagent you're looking at. Now, on this left-hand side, this 1, 2, 3, this describes your starting product. So that's not what's on the arrow, it's like what's right in front of the arrow. And it's primary, secondary, and tertiary. Have you guys heard those terms before? I'm seeing some nods. Would anyone like to define them for me? It's a safe space, guys, I promise. Take a stab at it. You were right last time. No. Okay, it's okay. So usually this refers to our level of substitution. So the way I like to think of it is how much stuff is connected, right? And usually it's in terms of a halide for chapter 7. So if you have a chlorine or a bromine, you're counting how many things are attached to that. Does that make sense? Sweet. And it all ties back to those mechanisms because it's really going to depend on how substituted you are, whether you can go through some of these mechanisms. Here's another silly little meme for you guys. I'm not going to lie. 7.18 got me through module 3. It is a huge chunk of what will be on the module 3 exam is determining what reactions are happening when in order to draw the product. Right? Because if you don't know what reaction is going to happen, there's no way you can draw the correct product. It's a shot in the dark. So I would highly recommend when you're at home trying to write out this chart by memory. I would recommend writing it on the front page of your exam when you get it, because it is that helpful, right? If you are able to copy down this chart correctly, you're in a good boat. So, but wait, how do I know if a reagent is a strong base or a strong nucleophile, right? Well, wouldn't you know it, our good friend, the textbook, also has another figure for that, figure 7.17, which is a comprehensive breakdown of the different categories of reagents that you might come across. Usually you will not see one that doesn't match one that's on here. Like the professors, they're tough, but they're not that mean, where they're gonna be like, what about this reagent I made in the lab for my undergrad? Like, don't worry about that. If it's on the chart, you should know it. If it's off the chart, out of mind, out of sight, you know? So one thing I will note though, is you see up here how some of these have negative charges, right? So a very important thing to remember is when you're actually in the lab cooking things up, it's very rare to have a bottle of something that just has negative charge because that's highly unstable. It's going to be exploding the whole lab. So sometimes you'll see it paired with something like sodium, so Na in front of it. So you might see NaCl or NaBr. And let me tell you, so many people freak out because they're like, "Oh my God, what is he doing? Like I've never seen him before in my life." I promise you, he's just sitting there. He's for decoration. We call that a spectator ion. Its only job is to stabilize the reagent. It is not a new reagent. So please, if you take away anything, 7.18, and ignore Na whenever you see him. He's just there for vibes. Okay, so putting it all together, kind of showing you how we do this. Here we have a reaction, ooh, scary. And we want to determine what our reagent is. So like we said, the reagent is what is on the arrow. So we can refer back to figure 7.17. And when you know it, and he's trying to confuse you, trying to throw you off, ignore him. He's literally just there for a positive charge. What we really want to see is our cell. And if we reference our 7.17, we can see Cl falls under the category of weak base, strong nucleophile. So that's great because it helps us determine where we're looking at on our 7.18 chart. But remember, we also have that left-hand side of how substituted is our halide. So, we have a halide here. I'll ask you guys, how substituted do you think it is? Is it primary, secondary, tertiary? Secondary, sweet. Any other guesses? Anyone online? Do we agree with secondary?
Yes.
Okay, yeah. Delayed response from online, that's totally fine. So how are we able to tell whether it's primary, secondary, or tertiary? What are we looking at? Anyone open to the room, open to the audience. Awesome, great. So like I said, we want to focus on
Answer the number of substituents from the.
ooh, yes, the number of substituents from the halogen. Perfect. So if we identify our halogen here, it's going to be bromine. Half the time it's going to be either bromine or chlorine. Like we say halogen, it's really those two, the main culprits. And then we go down to this carbon right here, right? And we want to see, other than the halide, how many things are attached, right? And so sometimes I see people go 1, 2, 3. No, we count that whole group as just one. And then this group over here is another one. And that gives us secondary. So great job, guys. So armed with this information, we can go back to our 7.18, right? And we figured out it was a weak base, strong nucleophile. And we figured out that it was secondary substituted. So you can find the coordinate that corresponds to, and it tells us at this, or under these conditions, we expect there to be only an SN2 reaction. Any questions about that? Sweet. Are there any questions about these squares that are split in half? Like what if we had a
Yeah, go ahead.
oh, what did chat
Yeah,
say?
the tail of the arrow is coming from the same row, right?
Oh yeah. That was just clip art. Like it's meant to be pointing here, but I couldn't edit that part out of the clip art. I'm chemistry, not computer science, okay? But Some of these squares you see are split like 50-50. These ones, they're not even equally sharing the section, right? So what does this mean? Well, an important concept that you're going to come across in chapter 7 that I promise you professors will test you on this because it's the easiest trick question is the concept of major and minor products. And so basically in this example, you see how this SN2 square is like really, really big and this E2 square is really tiny. That's basically telling us when we do the SN2 mechanism, that's going to be the major product. That's the product we're going to get the most of. And our E2 is going to be the minor product. We get it in small amounts. Does that make sense? Awesome. So that's another reason I really love this chart is it also gives you a visual representation of what's going to be the major and what's going to be the minor. So now you might ask, well, what's going on down here with SN1 and E1? Because they're equally sharing. I'll be honest, SN1 and E1, they're not good reaction mechanisms. They're like your last resort when it comes to a reaction. So usually they'll be split 50-50. So if you ever get a question where you have a weak base, weak nucleophile, and it's tertiary substituted, and they say, what's the major product? There's going to be two major products, right? An SN1 and an E1. Sweet? Fair game? Awesome. So, like I said, for that particular reaction we were looking at, SN2 mechanism will occur as the only product. No major, no minor. And let me tell you, like I said, they love a good trick question. Sometimes they'll say, what's the minor product? When there is no minor product, okay? So make sure you know that chart in and out. So what about all the other reactions and all the other chapters, right? 7.18, he helps us with chapter 7, but what about when we get to chapter 8 and 9 and 10 and so on? Well, you can ask yourself a few guiding questions, and this is going to apply to most of the other reactions that you're going to learn. So the three most important things when you're approached with a new reaction and a new reagent that you want to ask yourself is one, about stereospecificity. Scary word, but it's a fancy word for are the molecules pointing in the same direction or not? That's all it means. So we see an example here, and if you don't recognize these, don't worry. These are from chapter 8, little peek at what's to come. Guys, are you familiar with what the wedges and dashes mean? Yes, maybe. What do they mean?
Wedge is pointing to the front of the page, and that's just behind.
Awesome. So in this example, we see two products that are very, very similar. So this 9 is from one reaction, and this 8 is from a different reaction. And notice the only difference between these two products is whether the oxygens are both pointing in the same direction, or if one points up and one points down. That's the only difference, right? So it's these minute details that professors are really going to be making sure whether you remember them or not. So the next thing that's super important, it's got another big name, regioselectivity. They like to give big names for no good reason, because all it means are the molecules added to a certain position on the molecule? So you'll learn a fancy name for it, Markovnikov or anti-Markovnikov, named after some guy. I don't know him. But we can see another example here where you see this first product, the halide is added to the same position as your methyl. Well, we have one where the only difference is that it's added one away from the methyl. That's what regioselectivity means. So knowing the slight differences in the position. So if you want to know the difference between stereo and regio, stereo tells you the direction in space, and regio tells you the position on the molecule. Make sense? Sweet. And then lastly, another important thing to know is, can it undergo rearrangement? Now, this one is a little bit of a more tricky question because it requires you to know about the mechanism. Remember those building blocks of mechanisms that we learned maybe 20 minutes ago, where one of them was rearrangement. So can, at some point, the molecule undergo rearrangement during its mechanism? And usually if it can, sometimes funky stuff will happen. So it's important to know. So an example of rearrangement here that's pretty common is called carbocation rearrangement. Are we familiar with what a carbocation is? What is it? Don't worry, it's okay. Like I said, definitions in Orgo are a lot more important than you would think. Do we have it in chat? Or is that an old notice?
It's an old one.
Oh, okay, my bad. So our carbocation, like I said, they're not creative, okay? Carbon cation. It means we have a positive charge on a carbon. Super unstable. So we see here we have this positive charge on this carbon. And our goal is to try and get it to the most stable position. So you can see here we have an approaching method rearrangement. We shift this over here and it changes the position of our carbocation. Can anyone tell me what is the difference? Well, actually, my bad. It's written right underneath it. Secondary versus tertiary. Our tertiary is going to be more stable, right? So if we have this rearrangement happening while we're trying to add things onto the molecule, you can imagine it can be a bit of a messy situation. So these are the three main questions whenever you're learning a new reagent that you should be asking yourself. Because you can see in these examples, it's going to be those minor differences that tell them apart. So no matter what, go back to your definitions and break down the material as much as possible. Yippee! So now we're gonna do a little activity. I got a Kahoot for you guys. I'll scroll back to the picture of the charts because they may come in handy. We got time for activity, right? Okay, good. Sweet. So we're gonna do the activity, and then I also did purposely leave some time at the end if you guys had any questions in general about studying or test taking strategies. So let me scroll up so we can get our charts. If you guys would like to take a picture, they might help you out with the Kahoot. Hint, hint, nudge, nudge. Everybody got it? Who wants it? Okay, sweet. And then mayhaps you might also need this one. Allegedly, apparently. And then can I move this out of my way? Would be wonderful. I can. Okay, so host live. And guys, we're gonna get Kahoot up in here. Kahoot. Too bad the sound's not working. I was ready to get down to some Kahoot music.
Yeah, that's true.
Sweet. Okay, cool. So I think that should be everyone. So let's go ahead and start. Hopefully it turned out okay. I actually have a test run with Kahoot, so
For fun.
remember, break down the definition. Remember, it's all in the name. They're not creative at names. Okay. So in that one, it was having a positive charge. So if we remember our nucleophile, right? That means it's a nucleus lover. So if it loves nucleus, it loves protons, that means it itself probably has a negative charge because opposites attract. So let's look at our scoreboard. Yippee. Okay. So what are the multiple choice questions at the end of the textbook called? Because some of these are study skill questions. Oh, here, let me You also move this. Or does it show up on your screens too? Okay. Hopefully the people online can actually, I don't think I stopped sharing my screen.
No.
Yippee. Oh, okay, a little switch up in our leaderboard. So yeah, that's gonna be our ACS styled questions. Now, what arrow pushing method is shown below? Yippee. So this one is going to be a nucleophilic attack. So the reason why is we have that oxygen and we had that carbocation. So even though that oxygen doesn't actively have a negative charge on it, another important thing in that definition is that it can also include partial negatives, can make you a nucleophile, right? Important thing to remember, they be hidden sometimes. So oxygen usually is going to have a partial negative on it. It likes to hog electrons. So it'll be attracted to that opposite charge. Oh my gosh, okay. So what is the name of the chart that shows you what mechanism will occur? I told you I don't play about this chart. She's figure 7.18. I did put a little trick in there. 7.17 is the one that tells you whether it's going to be a strong base, strong nucleophile when in terms of the reagent. But yes, 7.18, literally live and die by her. Okay. We got a lot of switch ups. So we got another arrow pushing one. Okay, so I can definitely see how we thought proton transfer, which is why I purposely put this one in here, thinking like a professor with the trick questions. So one of the main differences between a proton transfer and a carbocation rearrangement is number one, a proton transfer usually happens between two separate molecules, if that makes sense. So let's say you have like an oxygen on one molecule, it's going to go and snatch a hydrogen from a different molecule. The main difference is carbocation rearrangement happens within the molecule, right? You're only dealing with one. And another important thing is the carbocation. There has to be somewhere on there a carbon with a positive charge that's getting shifted around. So as you can see, these minor differences, prime picking for professors when it comes to asking questions on the exams. Okay. So what guiding questions can you use to help classify reagents? Yes, guys, all of the above. These are all good questions to ask. Yippee, yippee. True or false, the chlorine below would act as a nucleophile. Yay, okay, so we could already see through the first question to this question, we're improving, we're learning our definitions. So that one had a full negative charge, right? All those negatives means that it's going to be on the hunt for some protons, right? So that is why it's a nucleophile. You guys are on fire. You got a true or false? The textbook has a student accessible answer key. True, yes. Please make sure you're using that answer key. Because sometimes answer keys are kind of trash, where you'll click on it and it'll be like, the answer is 12, no context. But this one has in-depth breakdown on how it got from point A to point B. Okay, we stayed consistent with that one. So what will be the major mechanism of the following reaction. Now, this is where I said having those charts might come in handy. Okay, so this one is going to be E2. And you know what? I'll even give you a pro gamer hack. Whenever you see something that had as much, here, let me see if I can show you guys the molecule again. Perfect. Whenever you see something that has as much things connected to it as that, chances are SN2 is not happening. And that has to do with a very specific part of the mechanism. You guys learn about it. I don't know if you guys have learned about it already. It's called the backside attack. Yeah, that's legitimately what it's called, where I kid you not, if it's too bulky, there's no room for the reagent to do a backside attack. Don't you just love chemistry, guys? Ooh, okay, we got another switch up. Okay, so we got another one. What will be the major mechanism of this reaction? And again, you know, open notes. I'm not a professor. Yippee! Okay, so majority we got to our SN2. So if we look at the media for this one, this is one of the ones where, again, sodium's trying to distract you, trying to make you think that it's a different reagent when it's not. All we really care here is about the SH. And I do believe this is one where there might be more than one reaction that can occur. And then remember, we go by whatever one is taking up more space on the chart is going to indicate what's the major. Sweet. Okay, so let's go to our last question. Look. False. Please don't read the entire textbook. It's 692 pages and over 2,000 practice problems. Please. Every time someone tells me they're going to read the whole textbook, I shed another tear and I lose at least 15 minutes off my sleep. And you don't want to do that to me. So, but let's go ahead and look at our leaderboard. Yippee, yippee. Yay. Dramatic spotlight. Okay, drama. Yay! Okay. So hopefully this helped you guys kind of like process all the information I was throwing at you. Like I said, whenever you can interact with new content that you just learned, it's going to help you retain it so much better. So I'm going to hop on over to my presentation and go to my last slide. We have a little survey, but also I wanted to open it up to you guys. Do you have any questions when it comes to studying, test taking strategies, anything like that? Use bags. Anything about Origo? Anything we covered?
Could you explain the, I don't know what is VR and BN mechanism again?
Here, I'll see. Oh, can you explain the BR and DBN mechanism again? Of course. I kind of X'd out of the Kahoot, but we can go ahead and look at the chart. So that's going to require us to use 7.17. So if we start with 7.17, we can see DBN is classified as strong base, weak nucleophile, right? So that tells us the position across the top of the chart. And then let me see if I can see, because I need to know the other, there we go, tertiary substituted as well. That tells us what the left-hand side is going to be. So using that, we can find our position. So strong base, weak nucleophile tells us we're in this column. And then tertiary tells us what row we're in. And if we go to the point, we can see that we are only in the E2 section. There's nothing else, no other reaction that can occur. Does that help with the question?
Yeah, thank you.
Yippee, yippee. Okay, like I said, these two charts, great combo for solving these questions. Any other questions about test taking strategies, orgo, studying, anything? Yes. How do you know what's important to take notes on or not? That's a great question.
Too much, or like have too many notes or just rewrite the chapter.
Yes, I can definitely see there being way too much content in the chapter. So one way that's really good is to kind of, I'll scroll back up, see what is being focused on the most in these skill builder sections. So sometimes you'll learn new content in a textbook and you'll notice it doesn't really come with a skill builder question. And that's a good indicator that what it's telling you might be more of like a real world application or like a lab application and less what you're going to actually see on an exam. Does that make sense? Awesome. So if it comes with a skill builder, chances are it's something that's very easy to test you on. Whereas if it doesn't, it might be more conceptual. It might be harder to be something that's testable. But that was a really great question because look, I'm a major proponent. Do not read the entire textbook. It's way too much information and it's only going to make you feel burnt out, right? Another good way is I know the SI leaders and the peer tutors will usually release exam reviews closer to exam dates. And that is a pretty good indicator too of the style of question and like the distribution of the topics, because those are all students who have taken the class before and have gotten A's in the class. And for SI leaders, they're even required to sit in on the class. So they know the professors very well. They work with them behind the scenes. Make sense? Awesome. Any other questions about anything Corgo related? Do you guys have to take Orgo 2 eventually? Is that on the roster? Orgo
Currently taking.
You're currently taking, you're an imposter this whole time. Well, you know what? That's totally fine because I'm not sure if you know, the Orgo 2 final
Yeah.
is a combination of Orgo 1 and Orgo 2.
Yeah, this is like a good refresher.
Yes,
Very
because
good refresher.
literally for anyone who has to take Orgo 2, the Orgo 2 final is the actual ACS. So you notice how in this one I said ACS styled because it's not actually the ACS yet. When you get to Orgo 2, you take the actual ACS exam, which is about 70 questions. And I kid you not, the first chunk of it, just straight Orgo 1. Just straight Orgo 1. And they don't review it at all. They're like, you can review on your own time. So definitely when you get to Orgo 2, it's important to make sure that you are going back to those original concepts and finding a good balance between studying the current content, but also not letting the other one fade into the memory. Make sense? But also between you and me, the ACS is also come with a nice curve because it's kind of like similar to an SAT where it's graded based on how everyone did. So graded by percentile. So usually if you get like 70% correct on the ACS, that corresponds to like an A on your final. So don't be too stressed. Any other questions from anyone online or anyone in person? I hope this was helpful. You know, I'll go back because, you know, help a girl out. Take a survey. If you learned anything or reviewed anything. But yeah. Anyone online have any questions about taking the class, test taking strategies? Okay. Well, guys, I'm legally required to be here for the next 6 minutes, so maybe we need to start brainstorming some questions.